All right, how's it going, everyone? Welcome. Today you will see a new face than what you normally see. We'll give it a couple minutes, and we'll kick it off right away. I'm gonna do one thing, put up some text. Boop. And Aaron, I think your audio and everything should be working just fine.
Yeah, I think so.
All right, are we good to go, Aaron?
Yeah. Let's start this.
I don't know if I can hear you.
You can't hear me? Hello, hello. You can't hear me? Hello?
Maybe it's my audio, but I can't hear you. Are
Pretty
you
sure.
guys able to hear Aaron? Oh, you do. Let me figure something out really fast because I cannot hear him. Can you try again, Aaron?
Hello, hello,
Nope.
hello.
Let me get some headphones. Try one more thing. All right. Thank you guys for reporting the issue that it's purely on my side. All right. Can you try one last time, Aaron?
Hello, hello, hello.
Oh. All right. We are good to go. All right.
Okay.
Thank you, everyone, for patiently waiting. We've got our new episode of AI That Works today, and I think one of the things that we really wanted to talk about today was a couple of new things. One is Anthropic had a great article about how they went down recently, and I think it's just worth diving deep into that to go understand what happened, how does it impact you, and like how can we understand if that sort of stuff is going to impact us downstream in the future. Now that we have these runtime dependencies on these models. And then there's a bunch of stuff that happened on AI, on OpenAI's Dev Day, and I think there's some interesting stuff to talk about there as well.
Yeah.
So I'm Vaibhav, I'm one of your co-hosts for AI That Works, and normally I have Dexter with me. Dexter has some really cool things going on that I can't talk about yet, so hopefully he'll talk about it next week. But I was able to rope in my co-founder, Aaron, who I think is just as pleasant. Probably the show should just be him and Dexter on instead of me. But Aaron, you can give a brief intro and background if you want.
Yeah, thank you. Yeah, so Vaibhav and I met 7 years ago. Now we're doing a company together. And before that, I used to work at AWS in EC2 and then in Prime Video, and I worked at Amazon for like 7 years. And then I was like, all right, I need to do a startup now. And here I am now, making a programming language. So,
Which we
yeah.
all know is a great startup idea.
Yeah, exactly. So happy to be here.
Cool. I guess let's get right into it. Let's start off with the Anthropic piece right away. So I'll go ahead and screen share and we'll kind of walk through it together. Let me get the screen share going. Oh yes, we'll talk about prompt optimizers too. I think we'll have a fun time today. Oh, screen. So I think the first thing I want to go talk about is this one. So many of you probably have seen this, which is, oh, interesting. Which is this article that Anthropic wrote, or maybe you haven't, which was Anthropic recently had a downtime or like, I guess, regress quality issues in their models. And they had like 3 unique bugs that I thought were really fascinating and talked about how almost sensitive these models are to things that are both incredibly technical and also really hard to understand. So we figured, let's just talk about it. If someone in the audience has thoughts or questions that they want to bring up along the way, please do that as per normal, because we love having that kind of conversation. Yes, let me zoom in.
Yeah, there we go. Perfect.
And like, one second, I'm going to adjust my screen. I'm on a new screen today, so it's sadly not as efficient as I normally am. All right. Is the rule for a co-host that they must have a mustache?
I think so.
Sadly, I can't grow one, so I've got to find other people that are that can do it. Let's just go right into the first one. So the problems that these happen is that they happen mostly at large scale systems, if you're running a tiny model or a tiny instance provider, you likely will never run into these. But anytime we depend on these cloud systems, our business and our impact of quality can have a huge impact based on exactly what these model providers do. And the more that we can deeply understand them, the better we can report, like say we see a bunch of issues on Twitter, which I thought was one of the most fascinating things about what Anthropic reported here, which is that the more issues that we see, the better we can understand, is it a prompting issue, is it a model versioning issue, or is it a core infra issue under the hood?
Or
and once we know what to diagnose, go ahead.
The worst case, it's a compiler issue.
Yeah, the worst case, it's a compiler issue, which is like really only, not only is it not found in the model company, but based on the core compiler to go fix as well. But before we go into the issues, I actually want to talk about a really important segment that they talked about at the very bottom, which is, I think they have it somewhere down here, this part. And I think this is going to be more and more true and really applicable to every single person being AI pipelines. Anthropic doesn't really have too many like evals fundamentally on their system. What they really do is they scan for noise across Twitter because they're so popular, they can go do that. And they're like, what is the general sentiment of vibes that is happening when we release a new model? And if anything is going off in a really anomalous way, they know for sure that they have an issue. And that's, I think, when all of us think about building AI pipelines of any kind, this is one of the most useful kind of things for all of us to think about, which is like, how can we get a latent signal here that allows us to go track this? And what's really fascinating here is that this worked for years for them. This is the thing that worked. And now, at this current skill that they have, now it really failed. Because they were able to, there's some sensitive issues that almost like conflated together at the wrong time to make it not work.
Part of it is really just looking at like at tweets and just general traffic on social media. At Amazon, for example, we would just listen to like mentions of like what are people saying.
Really?
Yeah, and that was the way that we like measured how good the product. Like obviously there were other metrics like how long people stay and like watch movies and stuff, but a big part is just like what are the customers saying, and for this specific instance, only 0.8% of traffic was impacted in some cases, so you can imagine like how difficult it must have been to find that there was an issue. And yeah, we can chat about the actual things that happened here.
Cool. Let's start off with the first one. And like for people that want to go read this whole thing, definitely we'll link it. Let me link it. I'll link it in the email, and also I think it's in the description of the event. But for anyone that doesn't have it, I'll post it in the message as well. I posted in the chat thread. But the first one I thought was fascinating was actually about like context window routing. And a lot of people talk about large context windows. They're like, oh, let's use a 1 million token model at all times. But surprisingly, the fundamental issue that they had here was actually the fact that like when they used a million context window for like, I think what they said was like smaller context requests, it actually led to degraded performance. Now, this is very against what a lot of people tell you, which is like toss everything at the biggest model at all times. That is not always going to lead to good results. And I can tell you at least my intuition about why that is the case. But I always like to think of it in the form of like software engineers. Aaron is an amazing software engineer I get the pleasure of working with. But like if I toss Aaron a bunch of nonsense information and then along with the actual information that I want him to go do, no matter how good he is, fundamentally, he has to do work to both process the information out and also deal with the issue of like figuring out exactly what has to happen. So in that world, it would just be better for me to tell him exactly what I want him to do, and he'll likely produce a better output that I would be super happy with at the end, no matter how good he is.
Yeah, it's just like, yeah, you just have like a bigger model with a bigger context window, and we can talk about exactly like the mechanism by which people scale out these models.
Oh, you want to talk about scale? Sure, we can do that. So like, okay, let's talk about why this ends up being true. So scala draw. 1 second, I'm gonna make a little. Let's see. Can you guys see my scala draw? All right, Aaron, I'm gonna send you a link to this. Start session, copy link, and I will send this to Aaron only. Cool. Aaron, you should have the link. Yeah. So like, why does this kind of model run into this kind of issues? Well, let's talk about how. One second, I gotta switch the chat. Well, let's think about what the mechanism doing under the hood. Like, this is at least my understanding of how I think transformers work. I might be wrong, and if I am, please correct me along the way for anyone that's watching. Fundamentally, what you do is you write a word like the best soccer. Oops, can't spell soccer. Soccer. The best soccer player is.
Yeah, I mean, that's pretty good. That's pretty good.
Okay, cool. But like when you go do this, what ends up happening is all the mechanism is doing is taking information from this word and somehow trying to bridge it all the way over into like this word, and said we're trying to move information about like best over into soccer. And somehow this vector now doesn't just represent soccer, it represents both the concept of best and soccer. And then it's going to say, then it's going to want to translate some information from soccer and player, and eventually best and player also into here. So at some point, the vector represents not just player and soccer, not just best, but the idea is soccer, best soccer players represented. And as you go down this world, the whole point is the mechanism is just moving information between these bridges into each other in various bidirectional ways so that at some point the vectors represent something meaningful. And when you decide what token you want to generate next here, and anyone that disagrees with this is wrong, but when you generate what token you want to go generate here, you basically are just moving information around. So what does long context mean? Well, this bridging is happening across many token channels along the way. And as you increase the context window, the amount of effort it takes the model to go learn how to move information across all these vectors is different. And it's not the same as learning what it means to move across 10 tokens versus moving across 1,000,000 tokens. So just because a model is capable of taking 1,000,000 tokens doesn't mean that you actually want to go implement the full 1,000,000 tokens every single time. It might mean you still actually want to tell the model, it's like, hey, I want you to ignore these parts of the token channel and only move information between these vectors. So
Yeah.
I suspect what Anthropic does under the hood, and I don't know this for sure, is I suspect they have different variants of their model, some of which that have the full 1,000,000 context, some of which that have shorter context, and if they know what it can route to, then they'll prefer sending to the shorter context one, if they can. Otherwise, they'll send to a longer context one. I suspect they have some sort of distributed system here. Does that kind of make sense with how you understand these systems, Aaron?
Basically, you what I'm understanding is also that like you take this initial context that you trained on. So let's say it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yeah.
And then they're like, okay, each vector has like, each token has a position encoding essentially.
Yep.
And when you expand this into 1,000,000 tokens, you're basically taking this, expanding it all the way, and then basically you shortened the positions here. So instead of 1, you do like 1.5, right? And then 2, 2.5, 3, 3.5, etc. And so like the spaces are exactly, so it's rope.
Yeah. For those of you that know, it's exactly. So you can look into this, and this, you want to look at how rope scaling works if you're curious.
Yeah.
But fundamentally, the point is like, it's not zero cost to go and make the context window bigger. It comes at a different trade-off. It enables new things. Like you can recognize, you can give it the whole word, you can give it like all of Charles Dickens and say, what is the one word that is flipped? And it can go build that relationship with itself. But fundamentally, what it's really doing is like, you're also coming at a trade-off over here. So if your context can be expressed really tersely, a smaller model or a smaller encoding space can do a better job of actually understanding what you're trying to do with less precision loss.
So TLDR, if you get anything out of this, just use less context. And
use less context.
I promise you, your pipelines will be more accurate.
Yeah, and that's not to say, it's not to say specifically like artificially reduce your context. Use the least amount of tokens you need to represent your problem. That doesn't mean it's small amount of context. It just means the least possible way to represent your problem is the best way to represent it.
Yeah. Okay, so yeah, we had 30% of Cloud Code users that were impacted, and that's why people were like, "Oh, this model is bad now." And I feel like this is
Yeah.
happening with every coding agent. Maybe people get used to it, but in this case, it was funny because in the past, people get used to the model being good, and they're like, "Oh, I can't solve these problems anymore." But in this case, it was literally the model being worse. So it's like, no, it's actually just like spewing garbage in some cases.
Oh,
Um,
Charles said something really fascinating. The big models are all now pure decoders and not encoders. I did not know that. I can't verify that. If that is true, but I did not know that.
Interesting.
Josh asked an interesting question that I think we can come to in a second, which is like, is this really talking about generation steps, or are we talking about reading context inputs as tokenizers? The tricky part here, Josh, is like this stuff, like every generation, you basically have to go read all the previous tokens. So even if you add any tokens, like once you generate a message, you still have to go do the same thing again, and then you have to generate the next token. So maybe I'm misunderstanding the question, but like for example, a word here might be "or" might be the best word if the model is trained to believe that. And now once message generated, it basically behaves like all the previous words, and now you have to move mechanisms around. So I'm not understanding the question fully. Let's talk about the second one, output corruption. These are just bugs. Like this, there's nothing fancy here. It's just like, at some point they had a bug in how they were assigning high probabilities, and like a random token would just get high probabilities.
Well, I think there's an underlying thing in this whole article about GPU scarcity. And you'll see this from the first start in the document where it says we use 3 or 4 different providers and different ways of like serving these models. They use like AWS Trainium. I don't know if you scroll up all the way, Vaibhav. All the way. It says it's like on the next section, how we serve Cloud Code at scale. Yeah. So. They have like Amazon Bedrock, Google Cloud Vertex AI. So they're spread across all these different providers serving like cloud models. And then they have like AWS Trainium, etc. Each of them has their own sort of architecture. So they have to like manage these at scale, which is nuts. So they are trying to squeeze every single performance that they can in here. So that just leads to bugs. And at the end of this article, they said we actually just stopped using these performance optimizations because quality is better than just having these random bugs happen.
Yeah, I can at least say like I did a lot of high performance work in the past, and we did a lot of work where we take certain parts of the algorithm and write in pure assembly to make it really good, and like do a lot of SIMD work, and that does basically make the code what I call write once, read never. It's actually worse than read-only access. You can't read it. You can only write to the file because you can only mutate it because every other variant is pointless. And I think what they're doing here is running into very, very similar problems, where the work here is just like, and the performance optimization bug, I think is kind of related to the next thing that we'll talk about. But like basically, if they pick the wrong token at the output, you get total nonsense.
Yeah, I think this one is easier to detect for sure. It's just like,
this one, yeah,
nonsensical.
I mean, they just added some detection for like unexpected characters. I believe they just have some other model that they trained to be like, or like even some heuristics that are like, hey, if you're producing ASCII and you suddenly stop producing ASCII or produce some really esoteric ASCII tokens, can you detect that? And that's probably an easy thing to go get. I thought this one was actually where they spent the bulk of their time, and it's fascinating because like a very interesting like compiler layer misconfiguration that they had, and this I think digs into a lot of various topics that I thought are almost how to describe it, very, very nuanced. So we'll see if this is interesting to folks, and if it's not too interesting, we'll go faster to the agent stuff. If it is interesting, we'll talk more about it. But at a very, very high level, I kind of want some people to have a good understanding of how these top P sampling works and how the models pick these tokens. Because I think that fundamentally, once you understand that, then you can understand how these bugs can appear and how complicated these systems are to go build. So, okay, we've talked about this in the past. We're like, how does a model pick? Well, once these tokens are done, how does it actually pick this last token? It goes through the whole transformer architecture, and at some point, it spits out a giant list of probabilities. it spits out a probability for like every single token you have. So if you have like a 2 million token vocabulary, it basically spits out 2 million probabilities down here. And when it spits out 2 million probabilities, it basically says that. Sorry, I'm seeing the wrong thing. When it spits out 2 million probabilities, it basically says for every single token in the token vocabulary, what is the probability for it given the sentence here. So if messy is a token in the vocabulary, it will tell you the probability of the word messy in the sentence. If or is a word in the vocabulary, it'll tell you the probability of or. If M is a letter in the vocabulary, and these all are, I think, at least for OpenAI.
Yeah, but the main point is also that you have all this giant vocabulary and you're actually trying to speed up inference.
Yes.
So you actually calculate these probabilities in different chips altogether. Which
I just want to give people an idea of what that means. So like in this world, if I wanted to generate messy,
oh, you can't.
I will probably. Oh, I'm sharing the wrong screen. Whoops. If I wanted to generate the word messy, what I will end up having is I literally have token probabilities for each of these things. I'll have a token probability for M, a token probability for ME, token probability for MES, token probability for MESS, and then messy is not a single token, so I will not get that. So the whole point is when these models are generating actual token probabilities, I'm getting for every single token along the way. And what I really need to do
zoom in more
over here is when I go generate these tokens. Aaron, can you help me write in here and like get the M and the messy all the way down? What I really need to do here is somehow I need to go pick what token I need to go pick. What token is going to go next? Because once I have all those tokens, then I can decide which is the best to go. And there's a lot of valid candidates, even if I want to produce messy. I could produce M and then ESSI. I could produce me and then SSI. I could produce MESS and then a separate token for I. And all these are valid ways to produce the right answer. So even though as a human we just see the word messy, the model is actually picking some other. It could pick many sequences and come to the same conclusion of messy, without there being a right one. So all we get are token probabilities. Now the problem is, how do you pick the best token probability? Well, model providers do a variety of different things. What Anthropic says that they do is they actually they take the sum of all tokens that exist, and they basically chop off everything that falls below like a sum of 0.99 or 99. And why do they do that? Well, as many of you might have heard us say before, let me zoom in even more. As many of you might have heard before, floating point arithmetic is really, really hard. So rather than dealing with really, really small values that are completely non-linear, you just say, if I will take, instead of adding up to a cumulative sum of 1, which is what everything should add up to after softmax, we'll take the probabilities that add up to 0.99. And everything else we just trash. Like nothing else matters. So if there's one token that adds up to like 0.51 and another token that adds up to 0.48, we'll take these two tokens and nothing else. We'll just trash everything else. Well, I guess technically in this space we'll allow any other tokens we take up to like 0.99. And now we will only allow these tokens in and every other token is ignored. And that allows you to not get nonsense characters by accident when you go do this. Because what is temperature 0 doing? Well, temperature 0 says, given all of these tokens, take the one with the highest probability and basically turn this into 1. Oops. And every other token probability basically becomes 0. You basically build a filter at temperature 0 that basically makes everything else not matter. And all the way at temperature 1, we keep everything to be the same probability, and at temperature, I think, 2, it does some inverse distribution of it. So it basically reduces the value of the highest probability and makes it more akin to uniform distribution.
Yeah, so they keep doing all these like different hacks and stuff to account for various problems with like floating point math, right?
Yeah.
So in one case in December 2024, in the article, they mentioned that they had another bug that caused a performance regression where the top token was not chosen. So if you were using Claude like for whatever reason, for whatever like task, I would have expected the performance to be like atrocious because it's just not choosing the top token ever.
Well, sometimes. It wasn't ever. I think it was sometimes.
Oh, I see.
But I want to describe one more element of this. Like, how does this 2 million probability thing actually work? Because like the problem is, if you actually ever toss this at a GPU, and your token vocabulary is large, you can't actually do this on a single GPU machine. So what the further thing that makes this even more complicated is not just that we have to produce these token probabilities and make it work. We have to do this in a distributed manner. So what you end up actually doing is you end up saying that, and I don't actually know if any token vocabulary is actually 2 million tokens. So just please keep that in mind. I don't actually know what the token size is on that, but I'm just using an arbitrary number to describe the vocabulary. I think like what they will actually do is they'll actually run this in a batch process where like machine 1 will basically run tokens 0 to like 32,000 or like technically like 32K. Oops. And then machine 2 will take the next 32 tokens. 64, and so on. And what ends up happening now is, now that you have totally different token probabilities being produced across different machines, what you need to go do now is, how do you actually pick the top token? Well, on each of these machines, you need to go pick a relative top token. So instead of giving the central machine every single token, well, one way you could do it is you could tell a central machine, here's all my token probabilities, and now pick the best. Pick best from all, and that's one way to do it. But another mechanism that is really useful is you ask every machine, what what candidates do you want to propose? And if every machine provides their candidates, so not all of them, but a subset of them, then you do a central pick max. And the bug that Anthropic had in this scenario was that they didn't actually pick the candidate correctly from each of these individual machines due to and we'll talk about what the real bug was. But what the bug led to was each of these batches wasn't always picking the right candidate. And that led to the right actual global, what I would call the global top P, not being available, or top token, not being available in the candidates array. So then when you actually pick the best, the top token was just not missing. Now, why does this stuff happen? This stuff is where it gets really, really wild, at least for me, which is, it turns out...
The code? Yeah, there we go.
It turns out, well, this is the hack that they did for actually like propagating stuff down. It turns out we're back to floating point precision. So what ended up happening is they use 16-bit floating point precision most of the time, but sometimes the TPU compiler optimized using 32-bit optimization, and it never made a distinction of exactly when, it just did it sometimes. And what that means is the way that they were doing comparisons was really, really unlikely to be stable, because for those of you that have ever multiplied two floating point numbers together, like a times I have to go back here, I can't type, oops. In floating point math, a times b times c is not equal to c times b times a. Like it is very order dependent. And now what ends up happening is, not only is this true, but if you do floating point 32 versions of this one times floating point a times b times c, assuming everything is a floating point 16-bit integer instead of a 32-bit integer, these are not guaranteed to be equal, even if the order is the same. And like, if you're curious about why this is true, you can go into looking at how floating point numbers are represented in a very nonlinear way, and when you multiply them, small numbers just don't behave in the way that we model numbers to behave in our heads. So then what ends up happening fundamentally is just you get a comparison that said token A was better than token B, just flipped because it was really close to their boundary condition. It was like 0.59 versus like 0.501 or 0.509, and like you flip one floating point operation, and then which one is better flipped. So then the candidate that this one suggested was like this one instead of this one, or this one instead of this one, because of simple floating point maths around this.
Yeah, I highly recommend this paper as well from Thinking Machines that AJ has shared. We won't go into detail on it, but it also talks about other causes for non-determinism. And it talks about how sometimes it's not the floating point arithmetic, but like the batches that you run on the GPU and how they are processed. But yeah, this gets more like nitty-gritty into the details.
Yeah. this is a really, really good paper for anyone that wants to go super deep into it.
Yeah.
But fundamentally, I think the real takeaway here is that like we're all building these systems on top of systems that we have even less control over in any previous way we've had. So it's really important to really be able to quickly diagnose what are the areas of the system that we want to go build. My personal opinion is, and Aaron, I'd love to know your thoughts on this, but like a big takeaway that I had from this is like one, sometimes the model did get worse. Sometimes it's not in your head, and it did get worse. And any sort of system you build needs to have some sort of vibe check for you to have. You need some signal for you to really quickly detect that this is actually happening, and you need to decide how actionable that this is going to be. So in ours, in Anthropic scenario, they use Twitter, and I guess Aaron used Twitter or like other verbal mentions of AWS to know
Yeah.
if the systems are down for a while. And as you guys build products, you probably want to build some sort of indicator like that into your product pipeline, where you have like some lossy signal that is really noisy,
I,
but it alone is not enough.
I think the interesting part is that for every engineer that is new to the AI world in this non-determinism world, you're used to maybe working with distributed systems where like distributed systems are always in a constant state of failure, right? That's why when you call when you do an HTTP request anywhere, you should expect it to fail at some point. So you can just expect to have like a try catch or whatever of some sort. With these models, the failure is like so subtle that we need new mechanisms to observe these failures. And so observability is even more important than before. You just won't get maybe the endpoint itself like is down, like whatever, you get a 500 from the Anthropic API, but there could be other bugs just related to the actual model outputs that you need to be able to catch.
Yeah,
So
I think
that,
that's really, and like what's I think like Anthropic highlights that too. Is like they're not gonna stop doing their Twitter analysis. Like that is really good for them to know if things are totally busted. But I think one of the more things is like one, you just add more inspection. I don't think most people should do that for their pipelines. It's too much work. Like you should definitely unit test the most important parts of the pipeline, not the whole pipeline. Not worth it. Because Anthropic is so widely used in so many different scenarios and their use case is different, they just need to increase their eval pipeline. I think for anyone that's doing bespoke workflows, they don't need like hundreds of evals. They just need to look at their systems a lot more carefully. Like do the stuff Anthropic did before all this stuff. But I think one stuff that is probably definitely shared that everyone should do is this. You want faster debugging tool, like what Aaron says, like you really need to be able to introspect your system as quickly as possible because the minute a customer reports an issue, you want to know one of three things. Is it really a failure from the perspective of your infrastructure? Is it a failure on the perspective of your prompt? Or is it a failure on the perspective of like the model? And
yeah.
if you don't know which of those three things is, or if it takes you like 3 hours to determine which of those three things it is, like it's going to be hard for you as a team. Oh, I'm
Oh, yeah.
sorry. Let me close
I know.
Discord. Thank you for noting that. My Discord is running at all times. Um, it's going to be really, really hard for you as a team to make your system better because your feedback loop is fundamentally the only thing you have to ship a really, really good product.
Yeah, I think in general, you just go, when you deploy stuff, you should just deploy like slowly. Like this is some stuff that it's like the
Yeah.
golden rule at AWS when I was at AWS, like you don't deploy worldwide at the same time. I know a lot of people have startups and they just like push to prod immediately. If you can help it, don't do that.
So,
Um,
can I ask you a question? When do you think someone should deploy to prod? Or like what? How do you think about this as a startup? Like we're a startup.
yeah.
How do you think we should think about this? Like, should we roll out our changes all the time?
You should. So if you're a startup, you don't have the bandwidth to like set up all these like hosts and like, oh, you have a one box deployment and then it goes to all this stuff. And you could also be running stuff in serverless. I think using feature flags is a good way to do it, where you can just kind of like roll back instantly or deploy to services that let you roll back instantly. So for example, I don't know, if you're using Vercel, you can like one click roll back in like 2 seconds, right? So that's very helpful to do in these situations. And sometimes when you're testing whether like it's a prompt or is it a hallucination or is it a model issue, the first thing you should just do is roll back. That was actually one of the slogans at AWS. It was really like, don't be a hero, roll back. Like, you don't need to find out exactly what it is and like patch a fix or whatever. Like, don't ask questions, just roll it back. Who cares if you roll it back to like the day before? It doesn't matter. Um,
Actually, really, I like that framing
yeah,
because I
don't be
think that's
okay
actually
with
the
the
right way
rollback.
for a lot of these AI pipelines. Like, if your system has been working for the last 3 weeks, and suddenly you see like 5 pings from users that have been using your product already and expect it to work, something probably went wrong, no matter what it is.
Yeah,
And if you roll back and you still see the issue, then like maybe it is the model,
yeah.
maybe it is the infrastructure.
Right, exactly. So if you roll back and it's still broken, you know you've already eliminated one variable. So then you can be like, oh, it's a model. Let's switch models now. Let's roll forward and switch to a
Yeah.
different model. But yeah, I think should
I
we
want to talk
move?
about one more question that I thought Josh brought up that
Yeah.
was fascinating.
Then
How do you
we'll move on to
differentiate?
agent workflows.
Yeah.
Yeah.
How do you differentiate if it's a failure or hallucination? What are your
So
thoughts, Aaron?
yeah, so if it's a failure or hallucination, um, you can sort. It depends on what task you're trying to do. Like always, like senior engineer, it depends. So, for example, if you're like extracting data from bank statements, right, and like all of a sudden it hallucinated that the sum is some different number, you can actually calculate this programmatically, and you can be like, hey, do all these line items add up to the sum? And if they don't, you know that there's a hallucination. So there's like systems you can build around LLMs and around data extraction to make sure that it's not hallucinating. But I know a lot of cases are literally just like plain text, like qualitative data, like it just spit a sentence and you're not sure if it's hallucinating. I think having customer feedback is a really good start on just like like having users tell you if it's actually good or bad. And you'll see this in literally every AI product out there. There's like a thumbs down or thumbs up button. And even OpenAI is asking people to do thumbs. If
But
you
no one
use
does
Cloud
it.
Code, if you've been pinged by Cloud Code,
Oh
whether
yeah.
it's good or bad, it's like, is this good? Like they're asking people constantly. Like everyone, they're asking literally everyone constantly all the time if it's actually working. So you should do something similar in your app.
I um I have a question about that. How I guess like most people never click thumbs up, thumbs down.
I don't know if I don't
Have
know.
you? How many times have you clicked it?
You only need a small subset of users, and also like you'll click. For example, the times where I do say it's not good is when it's not good, right? When I'm unhappy. So I think the most unhappy people will always like kind of like try and give you some sort of feedback.
I also on the topic of like, is it a failure or hallucination? I'll tell you like one thing that I was thinking about is like, I think people don't really have a good definition of hallucination. I think it's a catch-all thing for like, something's not working, and I'll tell you why. Technically, if you define hallucination as things that are not that are not backed by context you've given it, every time I ask ChatGPT a question, it's technically hallucinating. It happens to align with how I perceive the world, and I believe it, so I don't classify it as such. And I think it's really, really hard to define that word. So I think the first thing that I would do is I would just go back to your product and like be more concrete of like what is it factually incorrect things where like I have context that it is rejecting or not taking advantage of. Is
Yeah,
it because I
every time it disagrees with me, I'm sure it's a hallucination.
Yeah, exactly. So it's really hard to go vibe that, in my opinion, of describing hallucinations. It's like I would just define that more concretely, and then you can know if it's a failure or hallucination more clearly. Because a failure is like the model is. Let me read Josh's thing. But the anthropic failure cause. I think Josh, I see which question you're trying to ask now, which is like in the case of Anthropic's failure, it's like the model is inherently just picking, or not the model. Anthropic is picking the wrong token with their algorithm for selecting the right token. So like, how do you know that that is going wrong versus your prompting strategy? Generally, what I think here is like it's really just about testing really fast. You just if you build a gut model for like, hey, the prompt isn't working in the way you want it to work, and you have some business metrics that you can tie to it. So like either users are leaving more, the chat threads are either increasing or decreasing in like number of messages exchanged, depending on what kind of application you're building. What I would say is you probably can build a proxy for like product quality went down. Once you know product quality went down, then you can figure out what went wrong. And what I usually do in this scenario when a model fails is, yeah, like if Anthropic is not working, I usually just talk to the GPT-5 or the equivalent GPT model, and I just see is that one working. Because, well, usually I stay within the same models and I bump up to the bigger and bigger model. And then after that, if that is still not working, I actually don't spend too long on the prompt. I just swap to a different model and a different model provider. And if that doesn't work, then I do a little bit of prompt engineering to see like, oh, what can I do to actually make this work? And I think you kind of have to build the right thing. And it's really hard to know if it's an actual infrastructure or model failure. John brought up one interesting point of like, can we not just set up experiments? In theory, I think this is the promised land that everyone wants, which is like the promised land is like we have some data set and then we run the data set with a bunch of prompts and it tells us good or bad. And then we say, yay. In practice, I don't think it's that easy because I think most problems don't have a definition of good or bad.
How many of you have like 100 samples of your prompt?
Exactly.
How many of you have built 100 different test cases for whatever prompt you have? I'm sure that some have, but most people probably haven't.
The magic number is 30.
But Anthropic's error rate was 0.8%. So they definitely need like a ton, right? But this is Anthropic. Obviously, they have like thousands. But if you have maybe 1% of your users being affected by something, like you just need way more evals.
And you need, it's not sufficient.
Yeah.
The thing is, it's not like, this is another good question. Like the theory is like one good evals help. The problem here isn't just like you want good evals. The problem is you need evals that span the distribution of the behavior your users have. So it's quantity isn't the thing. And good is such a subjective term, it's hard to define. So I worked on Face ID at Google. We have so many data sets of people, the same person, with glasses, without glasses, with a mustache, with a different haircut. Twins, siblings. You really need to really quickly understand every parameter. And I'll toss you guys something really weird. None of you probably expect that Face ID worked worse in Phoenix. And actually, this is true for a lot of things. A lot of things work worse in Phoenix. Anyone know why? Aaron, what's your guess?
Well, you've already told me.
Oh, shit, I told you. This is not as fun. But for everyone else, it turns out the temperature variation affects how cameras calibrate in Phoenix because it's so hot. In fact, a lot of things get messed up because of how hot Phoenix is.
Yeah, the materials expand.
Exactly. So like the calibration you store that tells you how the camera is perceiving the world is wrong. So now your Face ID is like your face is basically distorted like a funky mirror house, so it doesn't work anymore. And you would never know that if you didn't understand Face ID has that thing that you have to go deal with in Phoenix, Arizona. And if you've never dealt with Phoenix, Arizona, you probably wouldn't know, and very sanely wouldn't predict that to happen.
Yeah.
What Charles says is, I think, is the best thing, which is you use what you do is you ship data to prod, you collect that data, and you turn that
into
you turn a subset of that into eval data set. That is the only answer. Yeah. And that is a rolling, it's not a one-time task. That is a thing that you do forever because you have to constantly span how your behavior is changing over time.
Exactly. So yeah, I think,
anyway, I think
this is a good summary.
A fun thing. TLDR.
We can do a quick.
I'll give a quick TLDR and let's talk about the other stuff that I think we'll see if we can. I can stay a little over and we can keep talking. The TLDR here is like basically go and try and build a product metric to your system, build a really, really good debugging loop so it's not hard for you to actually go and like determine where the problem is. And I guess what Aaron says is don't be a hero and roll back. Like, go do that if you need to.
Yeah.
Cool. Let's talk about the next thing, which I thought was one of the most interesting topics. Before I do that, for anyone that's watching and is interested, we do this conversation every single Tuesday at 10 a.m. PST. It's myself, Aaron, and I guess now Dexter as well. It's called AI That Works. The whole point is to talk about real in-production scenarios. Generally, we try and show some live code along the way whenever possible. Today's episode I thought was just like more conceptually talking about some of the work that Anthropic did that I thought was relevant. So no code today. But we send out email summaries and then we have all the blog posts and podcasts recorded live. So hopefully you keep enjoying this content. Please give us feedback about what we can do to make it better along the way. Let's talk about the next thing, the agent builder. So OpenAI released some stuff.
Viva, why do you think everyone is building these? 11 Labs literally released their own agent builder.
So do you want to screen share and talk about what we're talking about first?
The agent builder.
Just so everyone knows, and let's catch everyone up.
Yeah, one sec.
While you pull that up, how often should you run evals in prod? daily, weekly, honestly depends on your use case. There's no specific, there's no global answer for this.
One second. Yeah, so here's one agent builder. I don't know if this will actually play anything. Oh yeah, this kind of stuff, right?
Yeah.
So you have a start, you hand off to an agent, there's a conversation, etc. This is
And
a
like we've all seen this in like N8N, but like OpenAI released one too, I think recently, right?
yeah. There's an 8N, there's OpenAI agent builder.
Yeah, Agent Kit or whatever they called it.
Yeah, so there's
And you want to zoom in on that image?
yeah.
Yeah. Many of you might have seen this. Like OpenAI released this thing. They released prompt optimizers, a bunch of other things. We just had a fun conversation about it. What are your thoughts, Aaron?
So one, I think this is just like a push to have non-technical users build these agent workflows, right? Because code is scary, right?
Yeah.
Which is also interesting because code is easier for people to write now because you can just write a prompt and like it'll write a bunch of code. But I think if you're in this kind of closed environment where, hey, you can just drag and drop these nodes and build something, it makes it more manageable and less scary. Another big part of this is just like integrations. So maybe there's a node that allows you to like integrate your Google Docs or Google Drive, and you can just create a little workflow and like, boom, everything is kind of working.
I think one thing that I think that integration point is super undervalued because like if I'm a non-technical user, think about how hard it would be, even if I had to use Claude Code or something and I could magically vibe code, to say that in the end I want you to produce a Google Doc as an artifact because Google Doc is the thing I'm used to, or PDF is an output that I'm used to. And I think what's really useful there is it's something I don't have to think about anymore. It's like I draw a little line to a thing that says write a Google Drive file and it mostly works. Now the problem is, the minute I realize that I actually need like very specific folder names and all this other stuff, then you're like, oh shoot, I'm basically writing code in the UI builder.
Yeah.
And I think it's like, are you still screen sharing?
Yeah,
Oh, yeah.
I'm screen sharing this. So this is an interesting part. So you start out building these agent builders, but eventually you're gonna need structured outputs, right?
Yeah.
Because the way to have unstructured data, like a user's message, talk to your actual program and logic, to do that, you need to transform unstructured data to structured data. You need a schema. So whenever you start designing your schema, that's where the problem begins with a lot of these agent workflow UIs. Because like, just take a look at this. Like, oh my God, like imagine someone trying to explain to you their schema and not having, then you use these outputs in like other fields and like you don't have type safety and all that kind of stuff, and it's just like, oh my God, it's
Yeah, I think it's really interesting though, because like while this part is super horrific here, if you go back to the other version,
yeah,
that is really beautiful.
yeah,
Like I look at that and I'm like, that is high value, and I can see why OpenAI did this because they're like, hey, like Lovable's out here making people make a lot of money, and like, why does Lovable need to make that money? We can make that money.
yeah,
Right? And like you can imagine OpenAI says, why don't you just write a box here on this box that says, this is a prompt and we'll generate some code that meets that prompt under the hood. And they just do the code gen over there with GPT Codex or something, and it spits something out. But I think the point that you're making here is like, while this is really easy with a true and false thing for it to go read, and a human can go figure out like roughly what's happening here, the more complex this gets, like think about what is a function. If like a lot of us on listening on the call are all engineers, a function is basically a repeatable version of a block here. That basically you repeat 2 times, because like 2 other places use it. It's merely a readability artifact. Because technically you could just like duplicate the code over and over again. But one thing I'm always confused about these agent builders is how do you build a function? Like, how do I build a repeatable unit of work that I can reuse over and over again? And I know that they have some sort of composition stuff that you can go do, but the ergonomics of that are something I'm always fascinated about. Like, how do you go do that?
The other interesting part about this is the naming of it. So it's agent kit, but and then here you have like a workflow with some agents as well interleaved.
I thought that was cool.
Yeah, it's cool. And in this case, I mean, these agents are probably doing like a bunch of stuff. or maybe
So
just a prompt.
let me
Maybe
ask you, as a
tells.
founder,
Yeah,
when you see this and you see literally every company in the world releasing this,
yeah.
what's the alpha here?
What's
Like,
the
what
what?
company has alpha in building this? Because like I think this isn't like a dead space. It seems somewhat
Well, I
useful.
mean, OpenAI said they spent 6 weeks to build this, right?
Okay, so okay,
That's
never
like
mind.
that's literally what they said. They spent 6 weeks. They just launched this. They used Codex to build it. So there's really no moat right now in like just building
So
these
what is the moat though?
these AI. I think for OpenAI, it's just the integrations with their existing models. Like for example, they could have a model that's only usable in this platform, uh,
Oh,
that you can't
that
use
is
anywhere else.
interesting.
And actually, that's what they did with Codex initially. Like Codex was not available in Cursor. You had to download the Codex CLI, and then many days later, it was available in Cursor. But that's kind of how you start building some sort of moat. The responses API is also a way to build moat. Why? Because it's just so different from the chat completions API, and they can just own more of the agentic loop. I think it's a better designed API, to be honest, but it is another way that you start building some
That
moat.
is true. Because now if someone uses a responses API, they need to conform to like supporting web search and all this other stuff that OpenAI now supports that people expect to
Exactly.
work.
It's like, how would that even work if I switch? Every time you use a model specific tool, by the way, you're basically entrenching yourself into that provider's mode.
Which is not necessarily a bad. It's kind of what happened in with
Yeah.
cloud, right? It's like I think Terraform was kind of this aspirational world in which like, hey, we don't need to care about cloud specific, and like for some stuff that is true, but it turned out like at some scale, like the cost of moving between clouds is so like the cost of moving between clouds is so hard
Yeah.
that you would never actually do that.
Yeah,
It,
like AWS works pretty well. People use it and they're like, yeah, screw this. Like I'll just be in AWS. It doesn't matter if they have a service that's
yeah,
only.
and then the value of like Terraform goes down a
Yeah.
little bit because it's not as useful because you just use AWS CDK.
Yeah.
And like what I wonder is in this model world, how does that pan out? My at least my thoughts, and obviously I'm biased, and I'm sure you are too, and everyone knows that.
Hmm.
Like I feel like the model itself is doing inference. The inference part is probably the least interesting and unique part now of building most pipelines.
Hmm.
I really think it's about how it composes with the rest of your stack, where the value is.
Yeah. Yeah. I think.
And like this lets OpenAI kind of explore that version of the stack.
Yeah, but like you're saying, how does this plug into your existing code or?
Maybe it doesn't need to because like Zapier is like
Yeah.
makes money, and like maybe this
Right.
is just like kills Zapier and like yeah, screw it. Like
I think it's very hard for right now a single provider to take like everything. It's just like the winds of intelligence change all the time. Like
yeah,
whereas like yesterday it's Claude, tomorrow it's Codex. There's like no loyalty to any of these providers, and there's still a lot of room to build something that works with anything, in my view.
yeah,
Um,
I think so.
So
Nice.
yeah, I think it's an interesting concept. I think it definitely helps a lot of people that are non-technical, and we'll see what kind of things people build. But I have seen some complicated pipelines, and this kind of UI just does not work if if you have more than like maybe 10, 15 nodes here. You're just like, what is happening? Um, so
That
yeah,
is true.
it's,
Well, yeah, and like maybe there's enough workflows in the future that are really simple, and it's
yeah,
okay.
yeah, I agree.
Um,
Um,
well, with that, we'll take a couple more questions if people have some questions about any topic while we're on. Um, but otherwise, we'll probably close it out here and then talk
yeah,
about interesting things. Aaron, what was your first thoughts back to your live streaming days?
back to my live streaming days. Dude, it's all good, all good. Let's see. See what models. What do we have in the chat?
Cool. Um,
Yeah, I think that's it for now.
uh, yes, there's this interesting. We use Dexter? So Dexter talked about a research plan implement workflow that we used in the past. I think we can both give our perspective on it and see how well it works. My perspective is I have found that it is useful for really hard tasks when I want to go do it, but for easy tasks, it sometimes feels like more overhead. It's like I think it's like any process that you would do as a software engineer. It's like any amount of process I hate, and I will do the minimum amount of process I need to get the outcome I want. So like when I was at Google, I freaking hated writing some design docs because I was like, why do we have to write a PRD, then a design doc, and then go ship it? Like when we all know what the right answer is, we've all talked about this before. We know the algorithm. Let's go and do it. And sometimes it's like, holy cow, this is a really ambiguous problem. There's like 7 different things that this might touch that many of us aren't familiar with, and the process of writing the doc is useful. What about you, Aaron?
So for me, in the research plan implement, I I have like my own template. I haven't used like Dex's one specifically, but I do go through like the approach of like, hey, create a markdown doc, like let's review it together, and then after it's done in a good way, then I'll start like coding, um, and then go from there. And if I don't like it, I'll just redo the whole thing. It's funny because we were talking about this, and there was a tweet about this where someone was like, it's funny that I can literally just have, like when I see a PR, if I don't like something, I can just ask the LLM to like redo the whole thing, even if it's like 1,000 lines of code. It's just like redo the whole thing. I don't like this approach. But if it's a human's PR, you can't really do that because they'll get mad at you. So you kind of just have to push the code and like live with that forever. And you can push hard and like redo it, but at some point there's like a limitation of like the human limitation of just like how people feel about their code. So I thought that was
What
interesting.
what stuff are you using to write code now?
Myself, I'm
Yeah.
using Claude a bunch, Sonnet for 4.5. I think I'm like flying with that. And then sometimes for like tricky problems, I do fall back to like Codex CLI. But I do
Why
feel
not use Codex all the time?
it just takes too long. It just takes too long thinking through things. I feel like I just go faster with Claude, and
Yeah.
I get similar outputs in a way.
The other thing that I've noticed Aaron does, I don't know if you noticed, is like we have a Slack channel where he added a bunch of, what's it called, coding bots to it, and we just keep tagging Cursor or like Claude in it with like random tickets, and we don't actually like consider it. We just look at it. We're like, oh, did this one actually work? Cool, we'll merge it, and we'll go read that code. It's like almost like we burn tokens for an opportunity cost that it might solve the issue, and if
And
it does, great. If it doesn't, trash it.
yeah, it is interesting that there is an overhead though of doing that where like now we have to go back into all these PRs. If you go to our repo, there's like a bunch of PRs that are open that are like just like stranded in there that we need to triage because we still need to test them out. Cool.
I thought that's an interesting question. Are people saving BAML to databases and allowing users to edit and update BAML code? We have a type called dynamic type in BAML, which a lot of people do use. Like we have where they can control parts of the schema. We also do have a way to run BAML dynamically. I know one team that does that. Most people just use type builder and the dynamic interface around it.
Yeah.
That said, we've been thinking about this because like I think the world of software is really changing because like you do want not like the UI builders are so fascinating because like non-engineers can actually engineer.
Yeah.
But I think what we really want to live in is in a world where like our engineers write kind of like the contracts that we want to abide by, and we want our non-engineers to be able to edit all the stuff but the contracts. And
Yeah.
in some ways, the type system is like the contract. So our engineers define the type system, and what if like non-engineers could edit everything but the type system? I think that's a really fascinating perspective that we've been thinking about.
Yeah. All right. I think it's about time.
Yeah, we should head out. But everyone, thank you for joining. We're gonna have another session next week. I think next week is gonna be a fun one. Dex and I have been planning. It's gonna be about actually like live coding. We're gonna vibe code a new feature from scratch in the BAML project using Dex's approach. So it'll be a slightly longer session, 3 to 4 hours, and you'll literally watch us code on the fly and just see how we collaborate and get stuff done. But really looking forward to it. If this stuff is fun, check us out. You can sign up over here for the next event, and always join the Discord for the Human Learner Boundary. And all the links should be in the email and the post notes that we submit.
All
All right,
right.
everyone. Thanks for coming. See you,
Thanks.
Aaron. Thanks for joining.
Bye.